Take up the math retake here. So f of 3, so that means we're going to use this equation, and the x is 3. So that's going to equal 5 minus 3 bracket 3, which will equal 5 minus 9, which then equals negative 4 is my answer there. Okay. Now this one here, h of x, so h of x, we're going to use this formula. And the x is going to be 4. So if I run this, I'm going to go 2 to the power of 4 plus 3. I don't know if it'll run the numbers. So therefore our answer is going to be 27. Because 2 to the power of 4 is the same as saying 2 times 2 times 2 times 2 4 times. Something's wrong with my answer then. 2 to the power of 4, 2 times 2 times 2 is 16, plus 3. So that's actually wrong. Let's do a little bit of this. So 2 to the power of 4 is 16 plus 3, which equals 19 is my answer. Now this one is asking g of f of x at 3. So first thing we're going to do is we're going to plug 2 into the original equation. So if I plug 2 into the original equation, I go 5 minus 3 bracket 2, which is 5 minus 6, which is negative 1. So that's f of x. That's f of 2, sorry, equals that. Then I'm going to use that answer and plug it into g of x. So I go to my other equation, so I go, I'm going to replace it with negative 1. And that's squared. Get over here. Minus 4 times negative 1, bracket, that's a minus, plus 2. So if I do the math there, negative 1 squared is 1, so that's just going to be 2 plus 4 plus 2, which equals 8. So my answer there is 8. And this one here, I give f of x equals negative 31. So that means the answer is negative 31. So negative 31 equals 5 minus, what is it, 3x. All right? So then we start rearranging. So I'm going to go negative 31 minus 5 equals negative 3x. Negative 36 equals negative 3x. Then I'm going to divide each by negative 3, so negative 36 divided by negative 3 equals x. I'm just going to press equals there, which equals x. So 12 equals x on that side. So I was actually finding x. I didn't give you x. We're finding x. Now this one here, same thing. I'm giving you x. I want to know my y is. Just like up here, as giving you my what is h at x equals 4. Same thing. What's y when x is negative 3? So if I take my red pen, I'll do this one in red. So I'm going to go to negative 3 here. Where's my insert? If I go to negative 3 and I go straight down, right, and then I go, so therefore, if I look at negative 3, my answer is negative 2. I'm going to do it again here. Let's go insert another line. I'm going to go 2.5. If I look here at 2.5, which I'll use green, it's right here, which is going to be 0. lastly, let me use blue. This time, I didn't give you x, but I gave you what it equals. So that means I'm going to go over to y equals 1, then go over until I hit the spot right here. And that is 5. Okay. So determine whether there are functions and state domain and range. So if I look at this one here, I know that for every input there's only one output. So if I look input, one output, one output, one output. Therefore, this is a function. It asks me to write the domain and range for it. So for this, since it's only points, we only have to write d equals and then list the points along the domain. So the x-axis, -4, comma, -2, comma, 1, comma, 3. Then we're going to do it again for range. Range equals bracket. I'm going to start from the bottom up, -2, comma, -1, comma, 2, comma, 3. And we're all done there. So, function or not here. So for the function part, we do the vertical line test, right? So if I draw a vertical line here, I cross it 2 spots. I cross here and here. So the vertical line test fails. Therefore, it is not a function. Not a function. Okay, so let's draw our, maybe I'll write it. Maybe not, I'll add it after. So let's do our domain. So domain equals, now we have a set. So we have a line, so it's going to be the set such that x, and I'm going to put the x in here. Now I know if I take a look, my low number is what? A 0. So let's go put 0 here. That's not 0. Okay. That's only my low number. So if I'm looking here, I'm looking for something that is, I'm going to put my line here, larger than 0, because it gets larger. So all it's going to be is larger than or equal to 0. And then it is a line, so I'm going to include the x is any real number. And then close off my set. So my range, if I took my range, it keeps going forever up and down. So realistically, it's just going to be this part here. Any real number, because it's going to continually go down. It'll be every possible y and continue to go up as well. So now I have to draw this. Okay. So it wants me to draw, make sure I draw a non-function. So I have to remember that. So let's draw my barriers. So my barriers is greater than -4. So 1, 2, 3, 4. So I'm going to put a line right there. And it's less than 0. Then if I'm going to go here, it's greater than -2. 1, 2. And less than 5. 1, 2, 3, 4, 5. So I wonder if I can actually put a box in here. So there's kind of my box that has to go into. How can I adjust my box? Can I make it dashed? No. Oops. I can only do that. Alright, so there's my box. So then I need a non-function, so I can pretty much draw anything I want in that box. I have to fill the space of it. So I'm going to draw something that looks like this. Anything that crosses over the vertical line test is not. If it fails the vertical line test, and I fill up my boxes and go all the way over horizontal, all the way vertical, it'll fit. Okay. Next one here, I need a function, so I know I have to have the vertical line test work. So my domain says it's equal to -3. Okay. So it's equal to negative 3. So oh, I almost messed up there. 1, 2, 3. So I know it's equal here. So it's only going to run along this. It says any real number. Okay. So I can actually put in an arrow. Because this would always be equal to negative 3. Plus, it would be every range number, every vertical number. So go up forever and be that number, and go down for number. That would be that number. So that satisfies both. Application. Okay. So state the zeros of the parabola. So what I want to do is separate these out, and I want them both to be equal to 0. So I'm going to go over here, and so it's x plus 5 equals 0. So that if I move the 5 over, it's x equals negative 5. So that's one of them. And the other one is x minus 3 equals 0. So x equals 3. That's when I move this over, right? And I'm moving this one over as well. When they cross over, they switch the signs. So let's mark those, because I kind of like marking them right away. Negative 5 and 3. So 1, 2, 3, 4, 5. And 3, 1, 2, 3. Okay, so now axis symmetry. Well, I know my axis symmetry is when I add these two, divide by 2. So negative 5 plus 3, and then I'm going to divide that by 2. Now if I do that calculation, I get negative 1. So I'm going to do this in blue. So I know my axis symmetry is right there. But the axis of symmetry is also my x-coordinate. So the x of the vertex. Okay? So I need the y-coordinate. So if I go over here, I need the y-coordinate. Let's plug in the x-coordinate into the original equation. So y bracket, y equals bracket negative 1 plus 5 bracket negative 1 minus 3. So this is going to equal y equals 4 bracket negative 4. So y equals negative 16. Correct? 4, negative 1. Yep. So that means it's negative 16. So I can put another dot here. Now, I realize negative 16 is not on here, so I'm going to make every dot here worth 2. So 1, 2, 4, 6, 8, 10, 12, 14, 16. Right, and there we go. We can sketch the graph. So if we sketch it with some perfect lines here, whoa, it's actually pretty good. There we go. I can kind of sketch my graph. And I could, if I'm really picky, if I don't want that dot, I could get rid of it if I want to. Or if I want to leave it there, I could. But you'd label, nice labeling job would be I'd label my axis symmetry, which would be my axis symmetry, my vertex, and such. Right? If I wanted extra marks, I could label these as well. Negative 5, comma 0. One over here. What's that? 3, comma 0. Boom. So, next question. State the zeros. So once again, we're going to separate them. Make this equal to 0. Make that equal to 0. This is the easy one. This is where x minus 9 equals 0. X equals 9. Easy. This one, we have 3x minus 9 equals 0. So let's move the first over. 3x equals 9. Oops, 9. Then we have to move the 3 over, so 3 equals 9 divided by 3, so x equals 3. So there's my zeros. So let's label them, because I always like doing that. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Axis symmetry is the two sides added together, so 9 plus 2 divided by 2. Add them up, divide by 2, and there's my axis symmetry. And that equals 5.5. Yep. So realistically, if I want to label it, 3, 4, 5, it would be in the middle here. Oh, sorry, 4. Well, I put the wrong number in. That's why it didn't make sense. I couldn't figure out why I didn't get my number I liked. 6. So 4, 5, 6. You can see there I made a mistake. But when I don't put the dot in, I knew it wasn't even between them. So that's why I kind of stopped and went back and looked at my answer and double checked. So coordinates of the vertex, I'm going to plug in this to the original equation. So that means, now don't forget, here's where the negative 0.3 comes in. Bracket 3 times 6 minus 9, bracket, bracket, 6 minus 9. So negative 0.3, bracket, that's 18 minus 9, and negative 3. So negative 0.3, I'm going to use times here so that it does my calculation for me. 9 times negative 3. 8.1. 369 minus 9, 9. Good. So 8.1. So let's mark it on my thing. So I'm going to go down. I'm going to go up 8.1. 1, 2, 3, 4, 6, 7, 8. Maybe a little more up. Oh, not my marker. Okay. There. And then I can draw it. So no way it's going to be as good as the other one. Boom. Good. And then a good graph, we kind of have the vertex labeled as 6, 8.1. Alright, so before a football game, the only thing would be a good idea to launch Max out of a cannon through the uprights and the waiting arms. Okay. So, I gave you a table of values here, so all you're going to do is plug in the numbers into, plug the t values into the equation to get what's happening here. So, if I were to show you the first one, and I shouldn't, so this is going to be h of 0 equals negative 0.1 bracket 0 plus 1 bracket bracket 0 minus 60 bracket. And that, if I plugged it in, so h is 0 would equal, let me plug in my calculator, negative 0.1 bracket 1 bracket bracket negative 60 bracket 6. So therefore I'm going to go in here and put 6. Now I'm just going to plug this into a calculator beside me. Therefore I can collect all my numbers real quick. So 10, if I go to 10, my number is 55. If I go to 20, number is 84. So I go to 30. So it's going to be 93. Now I could keep going here, but you get the idea. Now this here is first difference, 1 minus the other, so it's going to be 55 minus 6 equals 49. So 49, and then if I do this one here, 84 minus 55 is 29. The difference between these two are 9. And if you take a look at the difference between these two, that's 20. It's going to be negative 20. Now if we do the difference between these two again, it's going to be negative 20. And so on and so forth. So we know it's a quadratic because second differences. Right? So second differences. Now we also know, I didn't give you the right, set the formula right. If I FOILed it, if I FOIL the equation, it would have x squared. Let's write 2 up here. Therefore it's that. And then we could graph the value. So if we graph this, I'm just going to sketch it here. And that is, this part here is 60, right there. So it kind of looks like what you want. And this part here should be on the y-axis up a little higher. At what time does he land? He lands at 60 seconds. Because we can see it right here. That's where he lands at. Now bonus is how high is the cannon shot off. So that's at time 0. So the 0 would be 6. The bonus marks there would be 6 meters high. Last question. This is the question that got a lot of people. But that's why it is a Thinking Inquirer run. I'm not going to give you something that is going to be A plus B equals C, like a very straightforward one. I'm going to make you think about it a little bit. So we have this equation. H of D equals negative 0.0019 D bracket D minus 630. And I ask you for the zeros, or where it, I don't ask you explicitly for the zeros, but I ask you how wide it is. And if you think about it, how wide it would be is if that there is where it touches. So that would be considered the zeros. So we're kind of setting up a chart kind of like this, where it touches. So I'm asking for the zeros. And a lot of people came up and said, you only give me 1, because I could only separate this. I could only separate D minus 630. Right? And you're right, that's one you can separate. I could set it equals 0. D minus 630 equals, did I write D? No, that's 6. D minus 630 equals 0. Move it around. D equals 630. Right? Now, if you remember, the reason we zero these out is because along the x-axis, along the y-axis, right, or along the height will be 0 when these meet. So we need to make this part equal 0, or this part equals 0. So we already did that, and we take a look at the blue part. We go, okay, what could we put in for D to make that equal 0? What times this negative number equals 0? Well, any number times 0 equals 0. So if we plugged in 0 into that, 0 times negative 0.0019 is going to equal 0. So D equals 0. Now how far from the start of the arch is the middle? This is just a way of me saying what is the axis of symmetry, right? So how do we do that? We add up the two zeros. 0 plus 630 divided by 2. And that's going to equal 315. Okay, how high is the arch? That's the same as saying is what is the y of the vertex? Right? How do we find that? We take the original equation, which is this, and we plug in 315. So I'm going to use bracket 3.15, not 3.15, 315. 315, horrible time with my keyboard right now. Therefore, H comma D equals, I think the answer is 189. Negative 0.0019 bracket 315 bracket 315 minus 30 equals 188.5. Perfect. All right, so that's all the review. Take a look at it when you get your test back, and hopefully we can improve for later. Thanks.